Hello everyone. Today we're going to do a little activity to try to decide whether or not vector addition is commutative. Now, what does it mean to be commutative? Well, you might remember from your scalar algebra class that something is commutative or an operation is commutative if changing the order of it doesn't change the result. For example, scalar algebra, scalar addition that you've done pretty much all your life up to this point, right? If we take 5 plus 3 or 3 plus 5, either way we get 8, right? The order doesn't matter. So our question today is, does the same hold for vector addition? Remember, vector addition means that not only are we adding magnitudes, but also directions, right? We are adding vector quantities together. So this is the way the activity is set up, and you'll get an activity sheet to do this with, right? But in each case, you are given these 4 vectors, which I have cleverly called A, B, C, and D, on this nice grid pattern that you can use to draw on. And you're going to add the 4 vectors in different orders, draw the resultant vector, right? The net effect, remember, of the 4 added together, and then compare them and see whether it changed depending on the order you drew. So a couple of little instructions here. First of all, on your sheet, you have a dot, right, to start on, and it's important that you start on the dot because if you do that, it'll fit, right? Everything will fit onto your grid and you won't end up drawing off the side or something like that. If you do end up drawing off the side, something's not right. So remember, a couple of quick things. In order to add vectors, you have to draw them head to tail. Right? So if I was drawing A and then was going to draw B, I would start B at the head of A. Okay? Other thing you need to remember is that the resultant, after you've added the 4 vectors together, drawn them head to tail, the resultant is always drawn from the tail of the first, where you start, to the head of the last, where you end up. Right? From where you start to where you end is the resultant, the net effect of adding those 4 vectors. So you're going to do this several times, right? And then compare the resultants.